Okay, why is this not scientifically that great? You first, you were told to describe the structure and function of the enzyme pepsin and include relevant information on your task sheet at the back. It doesn't actually talk about pepsin in the introduction. Okay, so this is a bit of a problem. Make sure you talk about the structure and you put a chemical structure. Background information could relate to pepsin. It could also relate to background science as well that you think you'd use. Then, writing your hypothesis. This is a hypothesis. It's not the greatest worded one though. When you're writing your hypothesis, think about your aim. So your aim is to investigate the effect of temperature on the activity of pepsin. Okay, so then you write a hypothesis saying how you think the temperature will affect the activity of pepsin. If we do this to the independent variable, then this will happen to the dependent variable. The independent variable is what you change, the dependent variable is what you measure. The next sentence is a bit talking about pH. It's not really relevant to this. And the aim's down there. It's good to include an aim, but you'd probably put it up the top before the hypothesis and after a little bit of more background information. Then it says to identify independent, dependent, and controlled. Really good to clearly specify that, and I don't know that you know that from this introduction. Okay, results and method. We don't normally put them together, so method would definitely come before results. You'd probably have introduction, materials, method, and then your results. But if we just try and ignore the method and just talk about the results here, this table, we should have a table heading up the top. You can include all this raw data here, or you could put it in an appendix and just put the data, just do the next table. You could just include that next table, but that's okay. What you've done here, that's cool. Put this in order, so smallest to largest, so we can see a trend. pH should be P. This is fussy, but it's important. You will lose marks if you call it that. Initial mass, final mass, not these headings. Use the headings on your collated data sheet. That's all I'm going to say for that. And make sure you go table heading. Okay, then if we skip all the method, which shouldn't be there anyway, go to this table heading. Again, this should have a table heading. Not just table, table 2. Table 2, percentage mass change of tofu over a range of temperatures or something like that. Then your graph. You don't need to have a heading graph, just put your graph. You don't need a heading because you do a figure legend when you do graphs, okay? So you do figure 1 graph showing the relationship between this and this, okay? Now, labels are good, but don't talk about the pH solution. You should have talked about the pepsin solution. Percentage of tofu dissolved is good, needed a unit here. Only 3 points on the graph. That's a big bang bang, boing boing. You need more than that to show a trend. You don't really need that. Okay. Then also the last thing in results it says to do is to describe the relationships shown by your data. So just say state the relationships that your data represents. You don't need to explain it, just say it. Then if we move into the discussion, okay, the first thing we want to do is interpret your results with reference to science concepts. These whole 3 sentences tell you what you've done in your experiment, tells you nothing about the science concepts, so you don't really need them. Then you move on to this, which is cool. That's a bit of science. But then you talk about your hypothesis again, and then you just show the data that reflects your little bit of science, okay? So that one sentence of science is all the science concepts you're using to explain that trend, and that's really not sufficient. In week 8, you will have talked about enzyme learning. In week 9, you would have done collision theory, rates of reactions, all that sort of stuff. Both of those, temperature had an effect. Think about the bonding between the enzyme and the substrate, all that sort of thing. Shape of the active site. Think about collision theory, temperature. Enough hint. You can write a lot of science in this section, so it's really not sufficient science in that interpretation. Okay, then we move on to analysing your data by discussing the precision and commenting on reliability. I don't think reliability was mentioned in this bit of a problem. The next bit's about errors, evaluation your procedure by describing strengths and weaknesses, describe and justify improvements. You don't have to do it in the order that's here, as long as you've got it in here somewhere. But let's have a bit of a closer look. So they decided to start with their errors, which is cool. But they put their errors in 2 spots, there and there. I don't know why, but they did. Just put them all together. Make it make sense. This is a cool error. This impact is really an explanation of that error. and it's not really saying the impact on the experiment. So it's a good idea to show the impact. If you state that something is an error, then explain it, explain how that affected your results, and then evaluate whether that was a large impact or small impact and why. Improvements, it's cool to put improvements there. Is this really a systematic error? No, because it's happening in different ways in the different trials. Sure, it does happen in every trial, but in different ways. So therefore, it's not a systematic error because it's not happening in the same way in every trial. Okay, so again, this is again not a systematic error, it's a random error. Now, this is where they talk a bit about precision. Remember, precision is talking about how close data points together are at the same temperature. And we'll talk more about that in the next video. There is another video, but this is really not sufficient to talk about precision. Then this is about strengths and weaknesses. So they have one sentence which states that there are some, one sentence which explains that there is one main strength and specifies it, but doesn't really say why it's a strength. It's important. Then says there were more weaknesses than strengths. So it doesn't actually tell me what they are. I want to know what they are. So make sure you say what they are. And think about your method in this section. Really think about the method and think about you're saying a trend, you're saying you're supporting a hypothesis of some scientific trend. Do you have enough data to support that? Have you done enough things? I'm not going to tell you, but have a real hard think about your method when you go into this section. Again, this is a random error. Good was pretty actually the same as the first error though, if you just said it in a different way. Okay, so we've talked about their strengths and weaknesses. They've talked about improvements, which is cool. Now the conclusion. Write a statement in relation to your aim and hypothesis. Supports, refutes, or inconclusive. Does it? It says this has stopped my hypothesis from being clearly answered. What he's really saying is that it's inconclusive. This person got a little bit confused because they were expecting to see a straight line and they didn't. So they thought, ooh, something's going a bit wrong. In a way, it did support their hypothesis, didn't it? It did increase as the temperature increased. It did decrease afterwards, but it did increase it. So it did provide some support, but it also might have helped make them see more information. And if it did, you can say it provided some support, and then it also provided more information. Also talk about data points. It tells you to, so please do it. And then include a final sentence that sort of ties the relationship between temperature and enzyme activity. Then finally, in the references, good 2 references, excellent. Would have been great to see them incorporated as in-text references also. So have a bibliography of references, but also in your intro and your discussion, you should be talking about science, so you should be referencing stuff. Okay, hope this helps. Enjoy.